We are still in 5-6, constructing centers of triangles. This is going to be part 2 because I've already done the circumcenter and incenter. So if you're just now finding this, look at the description below, click on link 1. All right, let's turn the page and get it done. All right, centroid and orthocenter. Now, in my previous video, the one before part 1, we learned that a centroid actually comes from the angle, and it is the hitting the middle of the opposite side. So basically, I need to start, hang on a second, sorry. All right, sorry about that. I need to find the middle of every single side of the triangle and then connect the opposite angle to it. And if you're sitting there going, whoa, woman, say that one more time. I had to find the middle of AC. I can't just eyeball it and go, hey, there's the middle, and then connect B straight down to it. I wish it was that easy. It is not. I need to find the middle of AC. It's going to be somewhere right in here. I mean, if I were to eyeball it, I'd say it's somewhere like right in there. That's just me eyeballing it, though. I want to connect B to that. All right, so we got to find the middle. And that requires us to do a perpendicular bisector. So remember, I need to have my distance on my compass over halfway. So I need to open this a lot. So if I put my sharp end on the vertex A, not the letter A, the vertex A, I need to open up this compass so it definitely is more than halfway. Like I said, if I were eyeballing it, I'd say probably the middle is right about there. I've got my compass open more. All right, so I'm gonna make a perpendicular bisector. That means I'm gonna make a big semicircle. I'm not gonna change the measure here. I'm just gonna change it over to my other hand. Put my sharp end on the vertex C, not the letter C, the vertex C. If you're a brand new teacher, reiterate that, because these kids have never used a compass before, and they sometimes will put it on the letter for some reason. All right, so there's my X marks the spot at the bottom. There's my X marks the spot at the top. And I'm really using these intersections at the top and the bottom to find where it hits the side of the triangle. So I'm going to use my straight edge there to connect the top intersection with the bottom intersection. I'm not going to draw a line, even though it does over here in the kind of the directions. I'm really just looking for that right there. Yeah, there's your middle. So I'm going to draw, when I draw my line, I'm going to draw the line from the angle B to that, and that's your median. I'm going to do the same thing for AB, so I'm going to turn my paper just to make my life easier. All right, now I'm going to find the perpendicular bisector of BA. So I've got my sharp end on the vertex B. This is open, in my opinion, a little bit too much. So if I were to eyeball this, there's about the middle. That's my educated guess. I want my compass a little bit more than that. Okay, I'm gonna make a semicircle. I'm not gonna change the measure here. Pick my compass up, put it on vertex A, not the letter A, the vertex A. X marks the spot at the bottom. X marks the spot at the top. Again, I'm not going to draw a line like I did with the actual perpendicular bisector itself. I'm using the top intersection and bottom intersection to find where it hits the side of the triangle. So there's my top intersection, my bottom intersection, right there. There's the middle of BA. So if I'm going to draw a line, I'm going to draw it from C over to the median. So already you can see there's your centroid. There's your centroid right there. Okie dokie. Now if you feel better doing one more, I didn't do BC. Orthocenter is created from the altitude. Now an altitude is a lot like a height. You are going from an angle perpendicular to the opposite side. So I need to figure out where it hits. I need to figure out where it hits AC to form a right angle, not where it hits the middle of AC. That would be a median, and that creates a centroid. I need to figure out where it actually comes straight down and forms a 90-degree angle. So I'm not going to actually, over here is how you do it with a compass. I'm going to show you guys how to use a protractor, because I would bet money that some of you have never used one. Way back when, they actually taught us how to do this, and I want to say it was middle school, where I learned how to use a protractor, and somewhere along the way they stopped doing that. So, you know, whatever. All right. So to make my life easier, this is the eye. I want to put that vertex B in the eye of the protractor. 90 degrees, as you can see, it is straight down. So it's going to be somewhere like straight down, be like right there. Another way is, see this line right here? I like this way better. I'm going to lay the line of the protractor on the side AC of the triangle. And then see how if I move it right, I'm off. There's my 90. I want it to be straight through B. So I'm going to move it left, move it left, move it left, move it left, move it left. And see this line right here? I want it to come up through B. So it's kind of hard for me to do this looking through a camera. But that looks about right to me. If I were to continue this line straight up, it looks like it would go through B. There it is, right there. So there's my 90-degree mark. Okay, I'm gonna turn it. I'm gonna lay the line of my protractor on the side BC. And I'm looking at this line right here, starting up to 90. I want it to go through A. So you can see I'm having to move it right. Okay, that looks about correct. Looks like if I were to draw this line right and continue, I would go through A. All right. There it is. There is the orthocenter. So I kind of veered off from what they wanted me to do, but I felt like you guys need to know how to use a protractor. So I'm sure there's going to be a couple more times where we're going to need one, and I'll go through all the kinds of things again. All right, guys. So this is part 2 of the lesson, how to construct a centroid, which is formed by the median, and that's from the angle to the opposite side in the middle. And then the orthocenter, which is actually the altitude from the angle perpendicular to the opposite side. That means it forms a 90 degree angle. All right, guys, if you have any questions or whatnot, let me know. Ask your teacher, and I'll just continue with the next video. See you over there.